Hello everyone, myself Vinay Kumaram. I'm pursuing PhD in physics. So in this particular YouTube channel, I'll be teaching physics, chemistry, and mathematics starting from 8th standard till 12th standard. So if you want to learn physics, chemistry, and mathematics, then please do subscribe to my channel. So in my previous videos, I had explained about various concepts which are there in the 7th chapter of 9th standard mathematics, that was on triangles. So now there is last exercise which is remaining in this particular chapter, which I will be discussing in this particular video. So that exercise is exercise 7.3. So now we look into the first question in this particular exercise 7.3. Here we have a particular diagram given. So that diagram I'll just write over here. So there is one triangle like this. So this triangle, it has one line inside it. This point is A and this point is P. From this particular point, which can be named as B, and this point we can name as C. So here BD is one line and DC is another line. So this is one image what they have given in this particular first question. Here triangle ABC and triangle DBC are two isosceles triangle. So that means here they are saying triangle ABC and also triangle DBC. So that is this outer triangle what you can see here. This is ABC triangle, and you can see one inner triangle here, so that is DBC. So these two triangles are isosceles triangles. They have given that means AB will be equal to AC, BD will be equal to DC. So based on this data, you have to prove certain questions in this first question. So looking into the first question, in the first question you have to prove triangle ABD is congruent with triangle ACD. So now we have to prove triangle ABD is congruent with triangle ACD. So if you write the image of these two triangles, so one triangle is there like this, and we have one more triangle which is there like this, somewhat like this it is there. So AD B or ABD is one particular triangle, ADC is another triangle. So these two triangles you have to prove they are congruent with each other. So here in triangle ABD, so in triangle ABD and in triangle ACD, here AB is equal to AC. So this is because triangle ABC is an isosceles triangle. Because triangle ABC is an isosceles triangle, here AB is equal to AC. Here you can see AD is common side for both the triangles. So AD is equal to AD. This is because they act as, this particular AD acts as the common side for both the triangle. Similarly here BD is equal to DC. BD is equal to DC because here triangle BDC is also an isosceles triangle. So BDC is an isosceles triangle. Because BDC is an isosceles triangle, BD is equal to DC. Because ABC is an isosceles triangle, AB is equal to AC, and AD acts as the common side. So according to SSS theorem, so therefore according to SSS theorem, here triangle ABD is congruent with triangle ACD. So triangle ABD is congruent with triangle ACD because according to SSS theorem. So now we will look into the second question in the same first question. Here you need to prove triangle ABP is congruent with triangle ACP. So that is this particular ABP and this particular ACP. So I'll just write these two triangles here. So here if I draw this line, so this is A, B, C, this is P. So ABP and ACP you have to prove they are congruent with each other. So now here AB is equal to AC. We know that. So in this particular second question, AB is equal to AC. This is because triangle ABC is an isosceles triangle. So now BC is, so here AP is equal to AP, or before considering AP is equal to AP, I will consider the angle. So let us consider these two angles, that is triangle BAP and PAC. So angle BAP is equal to angle PAC. This is because in the previous question we had proved that triangle ABD is congruent with the triangle ACD, because here you can see these two triangle ABD and ADC are congruent, so that means these two angles will be equal to each other. So since these two triangles are congruent with each other, BAP is equal to PAC. Now AP is equal to AP because AP acts as the common side for both the triangle. So now you got SAS postulate, that is this side is equal to this side, these sides like AP is the common side, and in between these two sides you have an angle which is equal to each other. So that means according to SAS postulate, so therefore, or according to SAS axiom, so according to SAS axiom, triangle ABP is congruent with triangle ACP. So now we will look into the third question in the same first question. Here in third question you have to prove that AP bisects angle A. So here you have to prove AP bisects angle A as well as angle D. So that means here you have this particular AP line. So this AP line you have to prove that it bisects this particular angle and also it bisects this particular angle. So that means this angle and this angle should be equal to each other, and this angle and this angle should be equal to each other. In order to prove this angle and this angle are equal to each other, we have already proved that because triangle ABD is congruent with triangle ACD. So straight away we can write triangle, since triangle ABD is congruent with triangle ACD, this we have proved. We have proved this already. If this third question only if they ask separately, then you have to prove that ABD is congruent with triangle ACD. Then only you have to come here. Here because we are solving first question also, in first question we have already proved triangle ABD and triangle ACD are congruent. So directly I am taking triangle ABD is congruent with triangle ACD, which has been proved. So now because these two triangles are congruent with each other, here in the previous question itself we had showed that BAP is equal to PAC. So angle BAP is equal to PAC. So this is because triangle ABD and triangle ACD are congruent with each other. So therefore AP bisects, AP bisects angle A. Now we have to prove that AP bisects angle D also. So in order to do that, we can consider triangle ABD and ACD. So we know that, or since triangle ABD is congruent with triangle ACD, since triangle ABD is congruent with triangle ACD, here ADB angle will be equal to ADC angle. Here AP is also a straight line. So AP is a straight line. So since AP is a straight line, here in this particular image, if you see this particular angle, if you add with this particular angle, then the total angle should be 180 degree, and this particular angle if you add with this angle, then that should also, the total should be equal to 180 degree. So that is here angle ADB plus angle BDP is equal to 180 degree, and angle ADC is plus angle CDP is also equal to 180 degree. And we know that ADB is equal to ADC. So in the place of ADC, I can write ADB only. So this you can call as equation 1, this you can call as equation 2. So equation 2 I can write as ADB plus CDP is equal to 180 degree. This I can call as equation 3. So one more time I'll write equation 1 here. So that is ADB plus BDP is equal to 180 degree. So now here you can see ADB is there, here also ADB is there. So this CDP you can take to RHS and this BDP also you can take to RHS. So ADB, so equation 3 becomes ADB is equal to 180 degree minus CDP, and equation 1 becomes ADB is equal to 180 degree minus BDP. So here you can see ADB, the same elements are there on the LHS, so RHS should be equal to each other. So that means 180 degree minus CDP is equal to 180 degree minus BDP. So now you can take this minus CDP to RHS and this entire 180 degree minus BDP to LHS. So that becomes 180 degree minus 180 degree. When minus BDP is brought to LHS, it becomes plus BDP. So minus CDP, when it is brought to RHS, it becomes plus CDP. So here 180, 180 gets cancelled with each other. So BDP is equal to CDP. So therefore, this particular line AP bisects angle D. So therefore, AP bisects angle D. So we have proved AP bisects angle A and we have also proved AP bisects angle D. So now we will look into the second question in this particular exercise. Here you have an isosceles triangle ABC. So they have already mentioned in the question that the triangle ABC is an isosceles triangle. And in this AB is equal to AC, and we know that this particular AB is equal to AC. So in this particular ABC triangle, there is one altitude, that is AD. So altitude means this particular angle will be 90 degree. So if this is 90 degree, then this angle will also be 90 degree because BC is a straight line. And we know AB is equal to AC. Now we have to prove in the first question, in second question, AD bisects BC. So we have to prove AD bisects BC. That means basically we have to prove BD is equal to DC. So if we have to prove BD is equal to DC, then we have to consider these two triangles and prove they are congruent with each other. So consider triangle ABD and triangle ADC. So here AB is equal to AC because this is this particular triangle ABC is an isosceles triangle. Here you can see this particular AB acts as the hypotenuse of ABD triangle because here AB acts as hypotenuse because this particular angle is 90 degrees. So ABD is a right angle triangle and ADC is also a right angle triangle. So for ADC, AC is hypotenuse, and for ABD, AB is the hypotenuse. So now we have proved that hypotenuse are equal to each other. Now we will try to prove one side is equal to each other. So we know that ADB is equal to ADC, which is equal to 90 degree, since AD is altitude. So since AD is an altitude, that means altitude is the height of the triangle. So that means perpendicular line they have to draw from A to BC. So we have proved one right angle. So now one side we have to prove apart from hypotenuse, which should be equal to each other. So here you can see AD acts as the common side for both of the triangles. So AD is equal to AD because it is a common side for both this triangle. So common side. Therefore here we are getting RHS theorem. So therefore according to RHS theorem, So according to RHS theorem, these two triangle, that is triangle ABD, is congruent with triangle ADC. Since ABD and ADC are congruent with each other, then BD will be equal to DC. So therefore BD is equal to DC. That is because triangle ABD is congruent with triangle ADC. Now we will look into the second question. In the same second question, here they have asked AD bisects angle A. That is, this particular angle is equal to this particular angle. So here only we can see that these two triangles, that is ABD and ADC, are congruent. So here triangle ABD is congruent with triangle ADC. So therefore BAD will be equal to DAC. That is, this particular angle BAD is equal to this particular angle DAC, since ABD and ADC are congruent with each other. So therefore AD, that is this particular, these two angles are becoming equal. So that means AD is bisecting the angle A. So therefore AD is bisecting, so AD is bisecting angle A. So this is what they have asked in the second question. We have proved that. So now we will move to the third question. So here in third question you have two figures. So one is there like this. So one triangle is there like this, and there is one more triangle which is there like this. So in these two triangles, this triangle is named as ABC and this particular triangle is named as PQR. So here they have given AB is equal to PQ and they have given AM is equal to PN. So AM is equal to PN and they have given BM is equal to QN. Based on this data, we have to prove certain things. So two questions are there in this third question. So first you have to prove triangle ABM is congruent with triangle PQN. So here we have to prove this particular ABM and PQN are congruent with each other. Straight away they have given the data here, that is AB is equal to QP, AM is equal to PN and BM is equal to QN. All these three datas are given. So therefore according to SSS theorem, so according to SSS theorem, triangle ABM is congruent with triangle PQN. So now we will move to the second question in this particular third question. Here you have to prove triangle ABC is congruent with the triangle PQR. That is, the total triangle ABC is equal to total triangle PQR. So here in the question they have given AM and PN are median. So what do you mean by median? So if you consider any triangle, so if I consider this particular ABC triangle and if there is a median in this ABC triangle, then this is ABC and this is M. So remember, whenever there is a word called median in a triangle, then that median exactly bisects the base of the triangle into equal halves. So that is one concept which you have to remember. So based on this particular data, here they have told that AM is the median of ABC triangle and PN is the median of PQR triangle. So that means this side and this side will be equal to each other. This side and this side will be equal to each other. So since BM is equal to QN and BM is also equal to MC, so MC will be equal to NR. So here triangle ABC is already congruent with triangle PQR. So here we can write AB is equal to, so AB is equal to PQ, which is already given. So if we consider these two triangles, AB is equal to PQ, this is already given, and here this particular angle and this particular angle will be equal to each other because ABM and PQN are congruent with each other. So angle ABC is equal to angle PQR. This is because triangle ABM is congruent with triangle PQN. So here, since AM and PN, so since AM and PN are medians of triangle ABC and triangle PQR, since these two are the medians, therefore BM will be equal to MC. Similarly, QN will be equal to NR. So BM is equal to MC and QN is equal to NR. And we know the total line BC is equal to BM plus MC. And we know the total line, so this is the total line BC, which is BM plus MC, and this is the total line QR, which is QN plus NR. So similarly, so total line QR is equal to QN plus NR. So now we know that BM is equal to MC and we know that QN is equal to NR. So that means we can write this as 2BM and we can write this as 2QN. And we also know that BM is equal to QN, which they have already given. So since BM is equal to QN, since BM is equal to QN, QR can be written as 2BM. And we also know that BC is equal to 2BM. So here you can see in the RHS, 2BM is getting equal, that is RHS is getting equal to each other. So QR will be equal to BC. So therefore QR is equal to BC. So since QR is equal to BC, and initially we had proved AB is equal to PQ and angle ABC is equal to angle PQR. So angle ABC is equal to angle PQR, and we have proved that AB is equal to PQ. We have not proved, we have already given, they have already given this. So according to SAS axiom, so therefore according to SAS axiom, here triangle ABC is congruent with triangle PQR. So now coming into the fourth question, they have not given the diagram. You have to draw the diagram for this. And there is an altitude BE and there is an altitude CF. So it will be like this. CF. So altitude means this angle will be 90 degree. So if this is 90 degree, this will also be 90 degree. And B is also an altitude. So that means this will also be equal to 90 degree and this will also be equal to 90 degree. So using RHS congruence rule, you have to prove that triangle ABC, the total triangle ABC is an isosceles triangle. So here in the question, they have specifically mentioned using RHS congruence rule, you have to prove this, this particular AB is equal to BC, that is ABC is an isosceles triangle. So in order to do that, I'll consider these two triangles. So we'll consider these two triangles, that is FBC and EBC. So here this angle and this angle will be 90 degree and BC is common side. They have already given CF is equal to D. So now we will consider triangle FBC and triangle EBC. So in these two triangles, this BC acts as the hypotenuse because this is 90 degree. So opposite to 90 degree will be the hypotenuse. So here hypotenuse is getting equal to each other. So BC is equal to BC. This is because BC acts as the common side for both the triangles. And here one angle is equal to 90 degree, that is BFC is equal to BEC, which is equal to 90 degree. This is already given because they have mentioned CF and BE are the altitude. So that means this particular angle should be equal to 90 degree. That is BFC and BEC should be equal to 90 degree. And they have also given, and one more side we have to prove that is equal to each other other than hypotenuse. So now we can straight away take CF is equal to B. So this is because they have already given altitudes are equal. So according to right angle hypotenuse side, that is RHS congruence rule. So according to RHS congruence rule, so therefore according to RHS theorem, so according to RHS theorem, triangle FBC is congruent to triangle EBC. So now since triangle FBC is congruent with triangle EBC, here this particular angle FBC will be equal to this particular angle ECB. So therefore triangle FBC is equal to angle FBC is equal to angle ECB. This is because triangle FBC is congruent with triangle ECB. So since these two triangles are congruent, FBC angle is equal to ECB angle. So if you consider in triangle ABC, so in triangle ABC, this particular angle B is equal to angle C because FBC is equal to ECB. So here we have proved FBC is equal to ECB, that is nothing but angle B is equal to angle C. Therefore, according to theorem 7.3, so if you don't know what is theorem 7.3, you can refer my previous video. So according to theorem 7.3, the angles which are equal in a triangle, the opposite sides will be equal to each other. So according to theorem 7.3, since angle B is equal to angle C, therefore AB which is opposite to angle C and AC which is opposite to angle B will be equal to each other. That is AB is equal to AC. Therefore, triangle ABC is an isosceles triangle. So triangle ABC is an isosceles triangle. Now coming into the fifth question, here also they have given triangle ABC. So this particular triangle ABC is an isosceles triangle. That means AB is equal to AC. And here we have to draw AP perpendicular to BC. So we have to draw a perpendicular line to BC. This point is P. So AP is perpendicular to BC. So that means this angle and this angle will be equal to 90 degree. So now we have to prove that angle B is equal to angle C. Now we will consider these two triangles, that is ABP and APC. So consider triangle ABP and triangle APC. So here this particular angle APB is equal to angle APC, which is equal to 90 degree. This is already given. This is already given since AP is perpendicular to BC. So now we have got APB is equal to APC, that is equal to 90 degree. And we know that this particular triangle is an isosceles triangle. So AB is equal to AC since triangle ABC is an isosceles triangle. Now we have proved hypotenuse of these two triangles are equal to each other, and we have proved right angles in these two triangles. One of the side we have to prove they are equal to each other. So we'll take AP. So AP is equal to AP because AP acts as common side. So since AP is common side, AP is equal to AP. So that means here right angle is there, hypotenuse is getting equal, and one side is also getting equal. So according to RHS congruence rule or according to RHS theorem, so according to RHS theorem, here triangle ABP is congruent to triangle APC. Since these two triangles are congruent with each other, B will be equal to C. So therefore angle B is equal to angle C. And one straight way is also there to prove this particular question. Here since AB is equal to AC, that is ABC is an isosceles triangle, so the opposite angles should be equal to each other. The opposite angles to the equal sides should be equal to each other. So that way also, using theorem 7.3, directly you can say B is equal to C, or you can prove that these two triangles are congruent with each other, and then we can prove that B is equal to C. So here we are focusing on RHS theorem. So that's why I have proved the congruence using RHS theorem, and then I am proving B is equal to C. The angle B is equal to C. So all the questions in this particular exercise I have solved in this particular video. This comes to the end for the 7th chapter in 9th standard mathematics. So in my next video, I'll start the 8th chapter, which is on quadrilaterals. Until then, if you want to learn more physics, chemistry, and mathematics starting from 8th standard till 12th standard, then you have to subscribe to my channel. Please do subscribe to my channel and stay tuned with my channel. Thank you.